So now, I cannot say that since the reading of G is calculated from division, the percentage of certainty of G will be equal to the additions of the percentage of certainties of its constant readings. Remember, we have said that addition of fractional uncertainty is the same as addition of percentage uncertainty. Because percentage basically means what? Fraction. That's why you say fraction is percentage fraction. Alright. So if your reading is calculated by multiplication or division, or multiplication and division of other readings, the percentage of certainty of the calculated reading will be equal to the additions of the percentage of certainties of its constituent readings. Therefore, the percentage of certainty of G will be equal to the additions of the percentage of certainty of L plus percentage of certainty of what? Of M. Since the reading is raised to power 1/2, you have to multiply either the fraction of certainties or the percentage of certainty by 1/2. So the percentage of certainty of G becomes 1/2 times the percentage of certainty of each of the constant reading, which is 1.72 plus 3.84. If you do that, remember that this is in percentage. Remember, so if you do that, that will give you 1.72 plus 3.84, which is 5.56%, times 1/2. So the percentage of certainty of G is going to give you 2.78%. So reading G can be recorded as 0.592 plus or minus 2.78%. So the uncertainty of G is expressed now in percentage form. So that the absolute uncertainty of G will now be what? The percentage uncertainty of G multiplied by the what? Actual reading of G, which will be what? 2.78% of 0.592. Times 0.592 and this will give you the absolute uncertainty of G will be equal to what? 0.0165. So reading of G can therefore be presented as 0.59 to two significant figures plus or minus. You will see that we got the same thing. 0.2. 0.02. If the reading is in two decimal places, the uncertainty should be in two decimal places. Both of them should have the same decimal place. But the reading will be rounded up to the same number of significant figures as any of its constant reading with the lowest significant figure. So, and I go to another question. So, before we go to the other question, here are the highlights of these questions. Number one, after you've calculated for the reading you are calculating for, the reading you are calculating for is defined in terms of pi, so you use pi to calculate for the value of that reading. But when you are calculating for percentage of certainty, you cannot include the percentage of certainty of pi because pi is not a physical quantity, it doesn't have uncertainty. So if your reading is raised to a power, you multiply the percentage of certainty by that power, or you multiply the factor of certainty by that power, depending on the one you are using. So after you have done that, from the percentage of certainty, you can now calculate the absolute uncertainty. Absolute uncertainty will just be the percentage of certainty multiplied by the actual reading. Okay? Now, we go to another question. And the question we want to go to is as follows. The question we want to go to is as follows. So the question is this. Number one, the mass of a ball made of aluminum is given as M equals 48 plus or minus 2 grams. The diameter of the ball is given as D equals 5.3 plus or minus 0.1 centimeters. 5.3 plus or minus 0.1 centimeters. But this is basically showing that the diameter was measured using a meter rule. So let's say the diameter, okay, is given as, let's work with the same 5.3 plus or minus 0.1 centimeters. Okay, so question, calculate the density of the ball. To the absolute uncertainty of the density. So density is given as mass per unit volume, which is mass over volume. So if you look at this question here, you see that if you want to determine the volume of a ball, what you will measure is diameter. From the diameter, you cannot determine the volume. So instead of calculating for the volume first, if you calculate for the volume first, you will need to also calculate for the uncertainty of the volume. So instead of doing that, it will be easier for you to just express volume in terms of what? Of diameter. Since volume is calculated from what? Diameter. So that you don't have a calculated reading inside the calculated reading. So you first have to calculate this calculated reading with this uncertainty. So instead of doing that, why don't you express volume in terms of what? Of diameter. The volume of a sphere is given as 4/3 pi r cubed. And the radius is given as the diameter over 2. So volume becomes 4/3 pi d over 2 all raised to power 3. So this becomes what? 4/3 pi d cubed over what? Over 8. 4 in 8, 2. So I'm going to have v becomes what? Pi d cubed over 6. 3 times 2. So the volume is now what? Pi d cubed over what? Over 6.